Hey guys! So, I figured that before I posted the key for the study guide, I would literally go through the study guide and show you how to do all this stuff on here so that before you take your test, which is tomorrow, you will have the opportunity to see how this stuff is done. All right, so I got my study guide. I have my coconut LaCroix. This is the best flavor. Don't at me. Uh, let's get right down to it. Okay, so for this first table, it says fill in the following table with information about each part of the atom. Which, of course, we know the parts of the atom are the protons, electrons, and neutrons. So when I see symbol, I know that the symbol for a proton is a little lowercase p and then plus sign. If I'm feeling fancy, technically that should be what we call a superscript. So I can highlight that, format, text, superscript. Should be a little positive P up there. Likewise for electron, do a little lowercase e for electron, and then I can do the same thing. Do text, superscript. Ooh, what's this? Control and then period. So do that. Let's try the shortcut. Let's try hitting control period for a neutron. Neutrons are N and then Al control period. And it has a little O at the top for neutral. So the symbol for a proton is P plus, an electron is E negative, and for a neutron it is NO with a little positive, like a degree symbol. Next, we need to talk about the location. We've only got two locations in an atom. We've got inside the nucleus and then orbiting around outside the nucleus. Protons, those are inside nucleus. Electrons, those are the little ones that orbit around the nucleus. So around nucleus. Or I could just put outside, or I could put in an orbit around it, however you want to say it. And the neutrons also in nucleus. There we go. Relative charge. Remember, protons are positive. That's why the little symbol has a little positive next to it. So positive. Electrons are negative. That's why the symbol has a little negative sign. Negative. And then neutrons are neutral, which is why we have a little O next to those. And then our mass in AMU. Remember, an atomic mass unit is just the weight of one proton. So a proton weighs one atomic mass unit. If you've got one proton, it weighs one AMU. Electrons don't have a mass. Rather, the mass is like super tiny, so you don't actually notice it. It's negligible. So we just put 0. Electrons don't have a mass. Protons do have a mass. And neutrons also have a mass of 1. There we go. Boom. Just knocked out the first part. All right. Reward myself with some LaCroix. Delicious. Not a sponsor. All right. So this next table asks us to fill in the blanks on the table using the information already found within it. So notice how when I look at this, I first read the directions carefully, then I start working on it. If I just look at the table, then I'm going to be like, I don't know what any of this is. The directions help me know which way I'm supposed to go here, what I'm supposed to do. So let's see. I've got an atomic number of 7 and a mass number of 15 for this particular row. Need to fill in these other blanks. So let's see. This one's number of protons. Well, if I know the atomic number, well, that's just equal to the number of protons. That's what the atomic number tells me. So my number of protons is 7 for this particular row. Let's see. And because we're assuming this is a neutral atom because we haven't been told otherwise, that means the number of electrons equals the number of protons. So it's also 7. Bam. All right. And then we need to look at our number of neutrons. How do I find that? Well, I have the mass and the number of protons. I also subtract protons from mass number. 7 minus 15 is 8. All right. Now I need to go figure out what element this actually is right at the end there. I need a periodic table. Let me go get one. Got it right here. Got it right here, laminated. All right, let's take a look. Number 7. Let's see. Woo. 1, 2, 3, 4, 5, 6, 7. Ah, that's nitrogen. I know because I just looked at the atomic number on the top and counted across until I came to 7. So nitrogen, the symbol for that is N, one big old N. Make sure you capitalize it. So now we have a number of protons on the second row equal to 20. Well, if I know my number of protons, my atomic number is the same thing. It's also 20. And then my number of electrons is 20. Whoop. How do I know that? It's equal to the protons. The electrons are equal unless specified otherwise. All right. Then I need to get my mass number. Before, I figured that out by before when I was looking for neutrons, I subtracted protons from mass number. Now I know my neutrons and protons, so I'll add them up to get my mass number. Protons plus neutrons equals mass number. 20 plus 20 equals 40. Now I just need to find the symbol of the element. Well, let's see. That'll be 20 on the periodic table because that's the atomic number. When I look at that. There you go. Calcium, good for your bones. All right. Now for this one, I've got strontium, right? Yes. I have a master's degree. That's strontium. I'm sure of that. Okay. So I know strontium and I know the number of neutrons. That's convenient because if I know strontium, then I know its atomic number. I can find it on the periodic table right there at the top of the symbol. For strontium, that's 38. 38. There we go. That also tells me the number of protons. 38. And it tells me the number of electrons. 38. And then when I take a look at the mass number, well, I just add up protons and neutrons. 50 plus 38, that's 88. Did that all in my head. Big brain. All right. Then we look at this last row right here. I've got my number of electrons. Well, if I got my number of electrons, the number of protons should be equal to it. So that's also 30. My atomic number would then also be 30. To find my neutrons, all I got to do is subtract 30 from 65. Protons minus mass number will get me neutrons. That should be 35. And then let's see. So we're looking for number 30 on the periodic table because that's my atomic number. Zinc. Zinc. A lot of people don't know this, but zinc is good for healing wounds. So if you're bleeding, eat a big bar of zinc. I'm just kidding. Don't do that. Don't do that. You'll get heavy metal poisoning. Let's see. So that's table 2 all done. There we go. Congratulations. I'll give myself another small reward. These are good. Keeps me going. It's a good study habit. Give yourself small rewards as you study. Celebrate your small accomplishments. All right, so this next table, the directions say indicate which of the following elements are isotopes of each other. There's a question mark behind it because, yeah, sure. So let's see. If I have two atoms that are isotopes of each other, then that means, and this should also say atoms, not necessarily elements. What are you doing, Mr. Cruz? All right, so indicate which of the following atoms are isotopes of each other. Well, what is an isotope? An isotope is atoms that are the same element but different masses. So their mass number is different. If you're the same element, you have the same number of protons, because that's what determines what the identity of the element is. But if you want to change the mass, you need a different number of neutrons. So, in short, an isotope is same number of protons, different number of neutrons. Well, which of these has the same number of protons? Element 1 and 2. Different number of neutrons, 16 and 13. These are my isotopes. Now I need to indicate which two they are. I'll do that by just highlighting each of them. So I click right there, click that, and then I can highlight it however I want. Let's do, I am a big fan of green. It's my favorite color. Boom. It's a little dark, but, gets the point across. All right. You could have done that anyway. You could have gone into the draw feature and circled it. You could have made big boxes around it. You could have said, this one right here, Mr. Cruz, just typed it out. I don't care. I just chose to highlight it. All right. So now let's write the hyphen and nuclear notation for the following. That's my next table. And hey, I completed a table, so I'll reward myself. Boom. We are 3 for 3. All right. So an atom with 16 protons, 15 neutrons, and 16 electrons. And I need to write the hyphen notation for it right there. Well, what is hyphen notation? It's the name of the element and then the mass of the element with a little hyphen in between. So when I look at this, if I want to know what the name of this element is, I got to look at the protons. Protons are 16. That'll tell me where it is on the table. Number 16, well, hey, that's sulfur. I'll write out sulfur. That's the European spelling. Sulfur. We're in good old America. All right, then I put my hyphen. That's it right there. And then I need the mass. I'm not going to look at the periodic table for this because we're dealing with one specific isotope of sulfur. I'm just going to add up the protons and neutrons. 16 plus 15, well, hey, that is 31. So this is sulfur 31. There you go. That's my hyphen notation. Now I need nuclear notation. This one's going to look a little funky because it's hard to do a superscript and a subscript right next to each other, but we'll try it out. So for this, it's just a chemical symbol. And then to the left of it on top, I need my mass. And then below the mass, I need the atomic number. There you go. It's as easy as that. If you want to, you can try to do some funky superscript stuff. I can do that. And then let's see what happens if I do that. Looks a little bit better. But if you just want to write 31 and 16 and sulfur right there, just do your best to get one above the other. That'll work. But yeah, again, that's just the mass on top and then the atomic number on the bottom with the chemical symbol to the right of it. All right, so let's look at a helium atom with an atomic mass of 4. Well, hey, that's everything that I need right there. Helium 4. Boom. All right, when I do the nuclear notation for this, I'm going to have a 4, He, and I'm just going to do it the lazy way this time. Atomic number for helium, that's 2. How did I find that? I looked on my table. There we go. And then for this one, for people who got hard copies of this, might be hard to see. Remember, I told you to note that there's 4 little pluses in here. But on this, way easier to see. So let's take a look. Need to figure out what element I got. How do I do that? I count my protons. 1, 2, 3, 4. All right, so this is atomic number 4. 1, 2, 3, 4. It's beryllium. 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 This is why I love the periodic table. Ultimate cheat sheet. Tells you how to spell every element. All right, then my hyphen. Then I need to figure out the weight of this thing. So I just add up my protons and neutrons. So I'm going to ignore the electrons because they're floating around outside the nucleus and they don't have a weight. I'm just going to look at my nucleus. 1, 2, 3, 4, 5, 6, 7, 8. So this is beryllium 8. How do I write that in nuclear notation? Well, I put my mass on top, 8. To the left of that, I put my symbol, which is Be. I know that because of the periodic table. And then under my mass, I write my atomic number, which is 4. There we go. That one's done. Boom. High five, Mr. Cruz. All right. So let's create a rule for determining the charge of an ion by filling out the equation below using the symbols greater than, less than, and equal to. Okay, I can do that. For protons and electrons, a positive ion. What am I looking at here? Let's break this down. So I've got a table over here with one column that has positive ion, negative ion, and neutral atom. And then I'm trying to make the rule for it on the right here. I know that in order to have an ion, well, that's basically a charged atom. And in order to get a charge on an atom, I have to have some unequal number of protons and electrons. Protons are positive, so if it's a positive ion, I have to have more of those than an electron. So for a positive ion, protons are greater than electrons. For a negative ion, well, electrons are negative, so I must have more of those. So protons are less than electrons. And then for a neutral atom, there's no charge, which means that I must have an equal balance of positive and negative charges in my atom. So protons and electrons must be equal. Boom, knocked it out. All right, so fill in the table below with as many characteristics of metals, nonmetals, and metalloids as you can think of. I know that metals are shiny. I know that metals are ductile, meaning I can draw into a wire. I know that they're malleable. That means that I can pound them into shapes like a sheet. Now, ugh. I have a master's degree. I promise I can spell. All right. So let me draw. I'll put little dashes here to show that I've got a list. I know that they conduct heat. They also conduct electricity. How much? Oh, I'm doing great on time. All right. Shiny, ductile, malleable, conduct heat, conduct electricity. Let's see. I'm sure I'm missing very important ones here. Ooh. How about, while also conducting heat, they also have a high melting point. Boom. And they have a. Is there anything else that I can say about metals? Ooh. Tend to react with oxygen. That is one that I remember from the videos that I have been diligently watching on Google Classroom. I'm going to reduce the font of this a bit to just get it to fit on one. So for nonmetals, well, they have a lot of opposite characteristics. They have a dull luster as opposed to shiny. Let me add my little dashes. They are brittle. It's very hard to bend them or pound them into shape. They break instead. They tend to be poor conductors of heat and electricity. They are also, well, that's why they're so good as insulators. If you look at things like your insulation in homes between walls or jacket insulation, it tends to be made out of nonmetals. Then we also have the fact that they have a low melting point. Most of them are gases at room temperature, in fact, because of that. Now let's move on to the metalloids. Metalloids tend to be shiny or dull. They are uh, all right. They're decent conductors. You might even call them semiconductors. Semiconductors. Whoops. Let me add that. Bam. All right, and they tend to have uh, depending on the metalloid, they can be brittle or malleable and ductile. So I'll just go ahead and say they can be either or. They can be brittle or malleable and ductile. It depends on the metalloid that you're talking about. They're kind of weird. They're the in between elements. Okay, so I think that's pretty good for that. I'm actually going to backspace some of these. Again, I want it to fit on one page. It looks nice and neat. Now let's move on to this. I'm just going to do this for a few of these because I'm running out of time in second period, to be perfectly honest with you. Calcium. Oh, wait. What am I doing? I'm jumping right into the table without reading the directions first. Let me carefully read those. For each of the following elements, fill in the missing information. Okay, so I've got this element calcium here. I need to find the group number, the period number, the state of matter, the valence electrons, the Lewis dot structure, and I need to circle if it's a metal, metalloid, or non-metal. I always like to do this by picking the thing that is the easiest to figure out. Calcium, it's to the left, it's in this region of the periodic table, so I know it's a metal. Instead of circling, I'm just going to highlight again. Let's pick a nice like pink color. Boom. Look at that. Ooh. So, next, we'll take a look at state of matter. Now, this is something that I can just Google if I really need to. To be honest with you, I put a lot of exceptions on this list, and I apologize for that. State of matter isn't going to be something that will test you over in this unit. So, if you happened to just kind of Google each one of these, it's no problem. What I was trying to get at with this was that most of the metals tend to be solids. But for instance, I got bromine in here, and it's a liquid, and carbon, it's a solid. And that's a non-metal, and that's a non-metal. So sorry about that. I'll go ahead. I'll put them in the key, but understand that if you struggled with this, it's no big deal. These are solid. Calcium is a solid. A group number and period number. Let's tackle that next. What is a group? Well, I remember that it's one of these columns on the periodic table. Each group goes up and down. So calcium is one, two, it's in the second column, which means it's in group 2. So group 2. Periods are the rows that go across. I remember that from the video. And if I count down, that's my first row, second, third, fourth, and there's calcium. So it's in period 4. There we go. Valence electrons, how do I find those? Well, I just count across. 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and 8. Each group shares the same number of valence electrons, and I can find them by just counting across my main group elements, which are 1, 2, and 13 through 18. Calcium is, let me see if I can point at it without looking, right there. Did I get it? I did. Ha! Calcium's right there, so it's in group 2, which means it's got 2 valence electrons. There we go. Got that answered. And then I need the Lewis dot structure. This is something that I would probably want to go to Google Draw for. So let's see. Calcium. Insert, drawing, new. And then I'll grab my little scribble feature. C. A, doesn't have to look perfect. And then I just need to draw the number of valence electrons. So I got 1, 2. There we go. All right. So save and close. And then I can resize that to make it less miserable for the actual chart here. All right, so there's my Lewis dot structure. See how I went from one side to the next instead of drawing them both on the same side? That's important. We have a certain way that we draw Lewis structures to help us make sense of how atoms interact when they bond. For now, we're just practicing one atom at a time. It's important to build this skill for later knowledge. Let's move on to silicone. So this was pretty easy, so I'm just going to go straight down the list here. I can find the group number. All I got to do is count the column across. Here's silicone, silicon, and it's in group 14 because it's on the 14th column. So 14. And then I just need to go down the rows to find the period. Silicon's right here. That's row 3, which means it's in period 3. State of matter happens to be a solid. Valence electrons, well, let's just count across again. 1, 2, 3, 4. Silicon has 4 valence electrons. Boom. Lewis dot structure, I can do that because if I know how many valence electrons, I know how many dots to put around it. So insert, drawing, new. I'll use my little scribble. S, I. And again, I'm just going to do one dot at a time around for this. I've got 1, 2, 3, and 4. And then I don't need to keep going. I've only got 4 valence electrons. So I'll save that, insert it right there. Boom, I got my Lewis structure. Now I just need to circle where they are. They are they a metal, non-metal, or metalloid? Silicone is on the zigzag. It is one of our metalloids. So I'm going to highlight that. And let's highlight it in a nice blue color. All right. So then we get to tellurium. Let's try that one. Tellurium is right there on the periodic table. So that's group 16 because I count across and I see that it's in the 16th column. And then I'll go to period and let's see, let's count down. 1, 2, 3, 4, 5 is where I find tellurium in that 5th row. So it's period 5. Its state of matter also happens to be a solid. Valence electrons. Well, I just count across for that. 1, 2, 3, 4, 5, 6. So tellurium has 6 valence electrons. Boom. Let's draw the Lewis dot structure. Insert, drawing, new. All right, let's take a look at this. Get my scribble tool. Tellurium is TE. T. E. Again, doesn't have to be perfect. All right. And then I start drawing my dots. So 1, 2, 3, 4. Now I can go around again. 5, 6. There we go. So if I have 6, I should have 2 paired up and then 2 little lone electrons right there. All right. And why 6 dots? Because I had 6 valence electrons. Save 6 outermost electrons in the atom. All right. Boom. So there's my Lewis dot structure. And then this happens to be a metalloid. I know that because it's on the zigzag. And then I'll highlight this one. Let's do yellow. Do it like that. There we go. Okay, so that's the first 3 of them. I'll have a key up with the rest of this filled in, including the periodic table, which I'll outline the metals, nonmetals, and metalloids, and make note of where the valence electrons are, because that's what the directions told me to do. Thank you all very much. I got I got the Spanish version down here. Thank you all very much for listening. This has been the study guide demonstration. I will have this next to the key in Google Classroom. Remember to like and subscribe. Have a wonderful Thursday.